Hey guys, I hope everyone had a great spring break and feel pretty well rested and ready to finish the semester strong. So last week, or I guess 2 weeks ago, we talked about dependent sample testing. So our samples were paired, and we saw that every participant was measured in both of our samples. So we had equal numbers of participants in each of our samples. And this week, we're going to be talking about an independent sample t-test. Here we have different numbers of participants, or we could possibly have different number of participants in each of our samples, and the main difference is in this situation every participant is in only one of the two groups and experiences only one independent condition. And an independent sample t-test is measured on a distribution of difference between means. So because we have different people on each condition of our study, we cannot create a different score for each person. So going back to our dependent paired sample t-test, our measurements were from the same participants, so we could get a difference column and then compare the difference scores. But instead, we're going to be looking at overall difference between the two independent groups, so we're looking at their means. This creates a new distribution known as the distribution of difference between means. So we're going to work through this worksheet today, and I'll start by reading the scenario. Who you know matters. Employment statistics demonstrate that the more professional contacts a person has, the more likely they are to get a job. You would like to know if the numbers of contacts that students at Auburn University make while in school influences their perceptions on how likely they are to get a job after graduation. You decide to use the students from a statistics class to see if the previous research holds at Auburn University. You obtain a measure of students with few contacts and a measure of students with many contacts, and then ask them how likely they are to get a job following graduation on a 7-point scale, where 7 is equal to almost certain. Here we're going to use an alpha of 0.05 to test our hypothesis. So as always, we're going to start by going through our assumptions, and in the online lecture last night, you were given some new assumptions for independent samples t-test. So take about 2 or 3 minutes to work in your group writing out your assumption, whether or not we need it, and then provide an explanation for it. So then I'm going to give them 2 or 3 minutes to work on these and write them out. And then I'm going to go ahead and just call on people to give me one of the assumptions. We'll write it out. I'll just go through them really quickly. Dependent variable is scale. Yes, our dependent variable of how likely someone feels they will get a job upon graduation is an interval measure on a scale of 1 to 7 where we do not know what 0 represents. Populations are normally distributed. Here I'm going to talk about how we would have two populations because we have two different samples, and N is less than 30 in each of our samples. We have 8 observations in one and 9 observations in the other. Participants are randomly selected. No, we sampled from our statistics class, not all of Auburn University students. And the next new assumption, participants experience only one independent variable condition. I guess here I'm going to talk about an independent variable condition would be the whether or not they have few contacts or many contacts. And yes, this people that we measured either had a lot of contacts or did not have a lot of contacts. They weren't in both groups, so they're only being represented in one sample. And finally, population difference between means is 0. Yes, we can assume this based on our null hypothesis, and here we're looking at population difference between means because we are comparing our means, not creating a difference column. So the next is write out the full null and research hypothesis. So here I'm going to give them like 1 or 2 minutes to write out the null and research hypothesis. And I suggest starting with the research hypothesis when we're getting into these scenarios that are a little bit more difficult, just because it's easier to tell what you're measuring from the scenario, and then you can do the opposite of what you're measuring in your null hypothesis. So I'm going to call on someone to give me their null and research, or someone to give me the null, another person to give me the research. And I have Auburn University students with many professional contacts will be as likely or less likely to perceive they will get a job after graduation than students with few professional contacts. And then Auburn University students with many professional contacts will be more likely to perceive they will get a job after graduation than students with few professional contacts. The number 3 is identify the independent variable and its levels. Here the independent variable would be professional contacts and the levels are many contacts or few contacts. So number 4 is how are participants assigned to levels of the independent variable? What could we conclude from this assignment? And then I have a slide on internal validity. So here we had that participants were conveniently assigned. And then on my slide, I'm going to talk about the degree to internal validity is the degree to which we eliminate all possible explanations for why we got our results. So if our participants are conveniently assigned, you will have lower internal validity. And this is because we didn't really eliminate any other individual differences. They came to us as they are, so they could vary on gender, social status, things of that nature, and so we have a lot of individual differences in our sample, and some of those could contribute to why we got our test results. So going back to number 4, participants were conveniently assigned. We randomly sampled from just our AU statistics course, not all Auburn University students. We can conclude that there will be lower internal validity, and that there could be other possible answers for this test besides contacts. Moving on to 5, at the 5% probability rate of committing a type 1 error, what would be the associated critical values? So then I'm going to give them a second to get on the thing and look at their to get the table, look at their critical values. And for the T-crit, I got plus or minus 1.75. Now moving on to the calculations. So I know this is a little hard to show over video, but what I'm planning on doing is first explaining that for us to get, first starting off by getting the sample means for few and many connections, and then going on to explain that we need to get individual variances for few contacts and for many contacts in order to get our pooled variance. So I have them write out few contacts to get x minus the mean of x. After they calculated their mean for few, then get a deviation squared, sum up those values, and then divide by the degrees of freedom for x will give us our variance for x. And then the same goes for y, which will be the few and many contacts. So then going on to pooled variance, the equation for pooled variance, or the symbol for pooled variance, is s squared of p. So it would be the sum of squares for x plus the sum of squares for y divided by the degrees of freedom total. So here would be 5.48 plus 28.01 divided by 15 to give us 2.22. And then the really great thing about the estimated pooled standard deviation is it's just the square rooted value of our estimated pooled variance. So we're going to square root 2.22 and get 1.49. So then the next calculation that we need to get is our t-statistic, and we can't calculate the t-statistic until we've calculated our estimated standard error. And estimated standard error is the square root of the pooled variance divided by the number of observations in the sample for x plus the pooled variance divided by the number of observations in the sample for y. Square root that, and then I calculated it to be 0.73. So then we can calculate our t-statistic by taking the mean of x minus the mean of y and dividing it by our estimated standard error. So I think that goes through all of the calculations on question 6, and I have them all worked out, and I feel like I could do a better job explaining them when I'm actually writing them out. I know this isn't doing the best job through video, and I really apologize for that. But I do feel comfortable with the calculations. I have the formulas, and so I feel good about that. So moving on to number 7, based on the results of the test, what would be your statistical decision? So then I'm just going to call on someone. This is pretty fast. They can just look at what our critical values were and then see where our t-crit falls. So I'll obviously have this drawn out on the normal distribution. And here we will fail to reject the null hypothesis. It appears that students with many professional contacts will be as likely or less likely to perceive that they will get a job after graduation as students with fewer contacts. So now we calculate the effect size, and effect size formula is D equals the mean of X minus the mean of Y divided by the estimated standard deviation. So here we have 4.75 minus 5.33, our two means for each of our samples, divided by 1.49, which was our estimated pooled standard deviation. And that gives us a value for effect size of negative 0.39. So what does this effect size tell us? I'm going to have, we're going to go through the calculations with them, then allow them a minute to a minute and a half to write out an explanation. Should be pretty fast. So we can expect on average that any individual Auburn University student with few professional contacts will be 0.3 standard deviations less likely to be confident in getting a job than a student with many professional contacts. This is a medium effect size. And the reason that we're looking at few professional contacts is because we have a negative value and we subtracted the mean for few contacts from the mean of many contacts. So we're getting that the mean for few students is lower, and therefore that's why we have the negative value on effect size. Number 9, calculate the 95% confidence interval for the distribution of differences between means. What does this confidence interval tell us? So we're going to go through the formula. It's where t-crit times the standard error pooled plus the mean of X minus the mean of Y for our sample. So after I calculated those, for my upper confidence interval value, I got 0.97, and lower, I got negative 2.3. So we'll walk through those calculations, and then again, I'll give them a minute to a minute and a half to write up an explanation. And I got at the 95% chance level, we can expect the population mean for students with few contacts to fall 2.13 lower and 0.97 higher than students with many contacts. And again, this is because we're subtracting few minus many, and that's why we're getting these values. I'm looking at few contacts as opposed to many contacts. Finally, for the practical decision, Auburn University holds several career fairs every semester so students can make potential professional contacts. Suppose there is a career fair held 1 week from today from 2 to 5 p.m. Based on the research just conducted, would you attend the career fair? So I'm going to give them maybe 2 or 3 minutes to work on a practical decision, and I really want to encourage them in their groups to talk about this, but I feel like they're kind of, I noticed in class that a few of them are a little bit confused about how you tie in t-test results to the graph or FX size and things of that nature, so I'm hoping that maybe if they work in their groups, at least 1 or 2 people will know how to effectively add those in, and that will help the students who are maybe struggling a little bit more. Personally, I said no because we failed to reject our null hypothesis. So we were saying students with many contacts will be as likely or less likely to perceive they will get a job, so they feel about the same as students who have few professional contacts. We have although we have a medium effect size, it is on the smaller side, and it is negative, so we're saying that students with fewer contacts feel like they would fall a little bit below many professional contacts. I'm not really sure that would make sense, but and then for additional assumption, I just said for most people, career fairs are very nerve-wracking, so you don't necessarily present the best version of yourself, and then can kind of end up feeling not successful, and you feel like you didn't actually make any professional contacts, so it wouldn't be considered a successful event. So I hope that was somewhat helpful. I do feel a lot better about this material and teaching than I'm probably portraying in this video, and I'm really sorry that I'm confined to my room. I have the PowerPoint prepared, so I definitely plan to walk around while talking about our PowerPoint, and obviously I have my book for when we're looking at getting our T critical values to kind of walk around and point those out, and when I'm drawing my graph again, and walk around while I'm letting the students take a few minutes to kind of work through any questions that they might have. So I'm open to any suggestions or feedback. I'm hoping that I'll do a better job explaining this once I get up to the podium, and I'm working through it with the students. Always kind of help me, guide me in the direction that they're going, and so I'm hoping that this is okay, and I'm feeling pretty good about it though. And thank you so much for understanding and being so helpful. I hope you have a great spring break. Bye!